what I have been doing on geography of science, and then I think it nicely links to what I'm now doing on university rankings. So the work is together with Gaston Heimeriks, also at Utrecht University. And so where does this fit in? Well, I think what's an interesting trend in the literature is that there's increasingly more emphasis and interest in geography. And the main area where this is visible is in innovation studies. So there's geography of innovation. Only last week we had a conference in Utrecht with 200 papers and 300 attendance just on the topic of geography of innovation. And within that area there is a subfield emerging which I would call geography of science. And geographers actually have looked at science already for a while, and they are more interested in answering qualitative kind of questions. What are local contexts? Do local contexts matter for creativity? How do certain theories or instruments diffuse? What kind of collaboration and governance issues exist if people collaborate at a distance? Are there really regional or national styles of research? All those kinds of questions. But I wanted to do something more quantitative and use bibliometric data to look at geography of science. And that's why I choose another term, spatial scientometrics. And because scientometrics, of course, uses bibliometric data to say something about research, but they haven't really looked at geography that much, unless you would define geography also at the country level. But apart from the country level, very few people looked at regional or urban levels of analysis. And I did a review paper on that to see what had been done and at what levels of spatial aggregation. And there we defined actually three kind of topics people are interested in. So the one question in geography of science, or spatial scientometrics I should say, is about spatial distribution of research, for example, of output. Yeah, so what are the spatial distributions of papers produced in a country? And people from Toulouse, Michel Grossetti in particular, they have geocoded all the Web of Science data, and for all countries they know for each paper in what city it has been produced. And they found out, very interestingly, that the main trend in almost all countries is deconcentration. Yeah? So let's say the leading centers in most countries, like Paris in France, they are losing market share, so to speak, to other cities. And also in terms of citations, we see that smaller cities catch up with larger cities. So this whole rhetoric, that was one of their main motivations, this whole rhetoric about having to concentrate and making centers of excellence or regions of centers of excellence, they question. That has been published in Urban Studies for those who are interested. Another question that really, apart from a paper by Andrea Bonacorsi, no one really touched so far, is the question, are there actually economies in scientific research? Do people get more productive if they live in a city or a region with many other scientists? That's a classical geographical question that, of course, in economic geography has led to hundreds of papers, whether clusters lead to higher productivity, whether larger cities are more innovative than smaller cities, all those kinds of questions. But you could ask the same question about science, and that's also one of the things I look at today. But actually it is a very hard issue, because if you really want to look at productivity, you need not just the output measures, but also the input measures. And those latter type of data are very hard to collect at the urban or regional level for scientific research. Then a second topic which has been much more advanced is whether there exist spatial biases in all kinds of interactions within science. So for example, is it true that research collaboration, such as co-authorships, occur more often when people are co-located close by or instead of far away? And indeed there is a strong spatial bias, so most collaborations occur within regions or countries, even though that bias is slowly diminishing. And also for citation flows, and that's maybe more interesting, and there have been fewer studies on this, it has been found that there is a strong bias of scientists to cite people from their own country. And this is not only for particular countries, this is a general pattern. And that matters a lot for how we assess, for example, performance or excellence. Because if these biases are really persistent and strong, we should correct for that. Yeah, because if you then live in country with many researchers, only that sole fact already benefits you in that you are more likely to receive citations. So anyone interested in that, that's still an area that needs much more research in my view. Then a third area is about mobility flow, so labor mobility flow among scientists. Again, not much research going on. There is increasingly research on mobility of inventors, especially Francesco Bisoni has a big project on this. And you could do the same for scientists. So for example, questions like what determines the decision of scientists to migrate or to return. Yeah? So for many countries that lose their talent to the US, the question is how do we get them back at a later stage of their careers. And there's one or two papers even on conference attendance, the geography of conference attendance. So does it matter where you organize a conference in terms of attendance and where the people come from? And this may be a kind of fringe topic to you, but for geographers this is a hot topic because geographers are increasingly interested in temporal co-location. Yeah? So this idea that you need to be permanently co-located in a region to have thick interactions, to have all the benefits of co-location, that's now being questioned because in many activities, including knowledge production, temporal proximity is usually already sufficient to collaborate. And conferences are one of the main ways in which scientists organize this need for temporal proximity. Lastly, there is some work on, let's say, geography of citation impact. Then you don't look at flows of citations between two cities or two regions, but you ask the question, do certain papers with certain spatial characteristics have higher citation impact than other characteristics? And this is actually a fairly old question in our literature because I think already in 1990 people asked the questions, does international co-authored papers, do these papers have more citation impact than nationally co-authored papers or single-authored papers? And this kind of question has now been more refined by looking also at the distance of that collaboration and regional collaborations, etc., etc. And we can think of a host of other possible spatial determinants that could affect citation impact. For example, if you are in Paris, say in Paris, with so many fellow scientists in your neighborhood, does that already increases the chances of being cited? Huh? And those questions, I think, can still be analyzed further.
Sorry,
yes?
Does the first group include studies that look at the spatial concentration or Because I would think that that makes a huge difference.
Well, those people who geocode publications, they are in first instance not interested in the institutional types of university versus research institute. So what they do is they just count the number of papers produced by city A, city B. But you could argue, maybe this is what you were hinting at, that with universities becoming more prominent in most countries vis-à-vis national research institutes, say in France and Germany, there's like a comeback of the university. This may also lead to different spatial distributions, also different types of collaboration, maybe more regional missions and all that kind of thing. So that could be an interesting question to address. Yeah. Now that brings me to my next topic, and that also links to your question. What I'm interested in this talk is how we can study the determinants of university performance as you can indicate performance with bibliometric data. And I'm looking only at universities and not at research institute like the Max Planck. And this is already one of the limitations of university rankings, that they do not include other research institutes. They only look at university rankings. So some countries like Germany, they do not really have many high-ranked universities, but then there may be a Max Planck Institute just down the road, and they may actually collaborate a lot, but that's not accounted for. Now, the reason I came to this topic was that I discovered that Leiden University, the Center for Science and Technology Studies, most of you probably know this center because they have been producing so many bibliometric studies in the past. They started their own ranking, and it's you can check it on their website. There's also an Excel file, and you can start to play around with these data. And they actually try to follow a new guideline on how to do university rankings, because in the past there have been many rankings, but also a lot of discontent about the methodology and kind of indicators that were produced. And these are some of the criticisms that have been voiced. First of all, most rankings, they look at all activities of a university, so they don't discriminate between disciplines. Yeah? So, okay, that's one limitation. And they also do not acknowledge that output, types of output, of number of citations per paper, differ markedly between disciplines. They also do not discriminate between country specificities. For example, the role of national research institutes in the system can be much stronger in some countries than others. And maybe most importantly, they don't discriminate between different missions of universities. So the implicit assumption of ranking universities using a single indicator is that they are all part of a single system. They all have exactly the same objectives, so they can all be compared and ranked in the same way. Now, what I like of the Leiden rankings is that they do not come up with composite indicators that are a weighted average of many underlying indicators. They just give you single indicators on as many aspects they can derive from the Web of Science data, and they leave it up to the user what kind of indicator he or she finds relevant. And that's why in this presentation I'm going to look at 3 of their indicators. One is the mean citation impact of papers produced by a university, and that's field normalized, so it is controlling for disciplinary differences. So that's, you could say, a research performance indicator. The second indicator I'm going to look at is the share of university industry publications in all publications of a university. So that gives you an indication how much interaction that university has with business. And a third indicator I'm going to use is the share of international publications a university has over all publication. And this gives you an indication of their level of internationalization. Yeah, so those three research performance measures I'm going to look at, and I'm going to try to find variables, determinants, that can explain the differences in performance across universities. Now the reason I want to do that is actually twofold. My initial reason was to look at those variables to see which variables are really discriminating a lot in performance. And if we know that, then universities might use those variables to select the right set of peers for them to compare themselves to. So for example, if say medical schools always have much more citation impact than other universities, all else being equal, then as a university it may not make sense to compare your citation impact with a medical school. Yeah? Then the medical schools should consider themselves as peers and non-medical schools as another group of peers. Huh?
Isn't that what happens or not?
No, because there are some implicit notions about relevant benchmarking dimensions. For example, the age of the university. That's often said that universities that have been established very recently should not be compared to universities that exist for a very long time. So I'm not sure which ranking, but there is one ranking that produces a separate ranking for universities younger than 50 years. By the way, Maastricht University, some of you may know that, is ranked very high. Huh? But it turns out in my analysis that the age of a university does not impact at all the performance of a university. So yeah, it's in the head of the people that it should matter, but it turns out for the 500 largest universities that Leiden looks at, that it doesn't really matter. So I'm this is just an empirical exercise, yeah? And of course I have some hypotheses. The main hypothesis I have is that size is really important. And that already comes out of other research showing there's a very strong relation between the size of the university and the mean impact papers have in terms of citations. Why that is the case we can discuss later, because I don't think it is necessarily evidence that they are actually better or having skill economies. It can also be the case that they have more budget to attract star scientists. It may be the case they're citing each other a lot. And so further research should single out all these possible effects. Okay, now, I actually already discussed this a little bit. The global university rankings, the three main ones are SPRU, formerly known as Shanghai ranking, the Times Higher Education, World University Rankings, and QS, World University Rankings. They used to be together, now they split. But it turns out there are already some books about university rankings. That the first university ranking dates back from pre-war times. And it also turns out that if you also take into account national rankings out there are like 100 rankings already. Yeah? But these three, they are global and they are probably the most well-known. And they are actually very similar in particular characteristics, but the scores they produce on universities are very different. So an interesting observation people did, and I also checked it myself, the correlation between those rankings is very low. It's around 0.5. So that already shows that there's not really a consistent picture that comes out of of these different rankings. And of course, the top 10 may look a bit alike. Even there, you already have differences. But if you look through the whole list, there are many differences. But all three of them, they are multi-dimensional, so they try to take into account various aspects of university performance, which is good. But then they apply weights to make one score, which I don't think is really necessary. Let the user, this is maybe also what Andy Sterling always says about multi-criteria analysis, let the user play around with weights and decide what she finds important. They also tend to be size sensitive, and I don't mean that there is a statistical regularity that larger universities tend to be ranked higher, but what I mean is that they use certain indicators that in themselves are already size sensitive. Just think of the number of Nobel Prize winners. Okay, also if they were allocated randomly, larger universities already would have more of these winners. But sometimes they also use just output measures that are not divided by staff or things like that. I think they have improved a bit on this, but it can be improved further. They ignore the varieties of university missions, because they want to aggregate all the information into a single indicator. They also ignore disciplinary differences. Okay, they come up with disciplinary rankings, but in the global ranking, there are no discipline normalized weighting schemes. And that's what Leiden ranking does better. They look at, for example, in their citation analysis, they look at the field normalized citation impact. So they look at what is the mean citation rate of papers in a particular discipline and normalized by that. Well, we already discussed. They also ignore the fact that some countries have a very different university system with research institutes maybe much more important. And ironically, they say very little about teaching. I think the Shanghai doesn't have any information on teaching whatsoever, but they were established initially to guide international students in their choice for university. And as we know, in many universities there's not a very strong relationship between research and teaching. So then, by looking at research performance, students are actually misinformed about the teaching quality. Okay, but this is, I'm going to look in my own analysis only at research performance. But if you think about these rankings and how they emerged, it is ironic they say so little about teaching. Okay, so what does the Leiden ranking tells us? Well, it offers one-dimensional indicators, and many. Also using different methodologies like fractional counting or full counting, there are different counting methods. And the three I use I already discussed is the mean normalized citation score, which they abbreviate like that, the share of university industry co-publications, and the share of international co-publications. And they solve some of the problems I just discussed. They don't need to assign weights because they are one-dimensional. They are size insensitive, because here you look at the mean impact of a single paper, so that is not affected by, in nature by the size of the university. And these are shares, so they are size insensitive by construction. And for the citation score, it's also normalized by discipline. And actually it emphasizes different missions, and depending on the mission you have, you can look at different rankings. Now, this is what the data look like. So there are 500 universities. They selected the 500 most publishing universities. and this is already an issue in my statistical analysis, I don't cover all universities. Yeah? I only cover 500. They probably account for the largest share of publications in the world, because there's a very skewed distribution. Nevertheless, my dependent variable is not random, but it is determined by size, the 500 largest universities. But I think I can control for that, and I'll discuss it later on. Now, the citation score is expressed in a number between 0.5 and 2.1. And the shares, you can see here, the university with the smallest share of university industry only has 1%. Yeah, so only 1% of their papers is with industry. And the one that's most prolific in that sense is 16% of their papers with industry. And the mean being 6%. International, it's much higher, so it ranges between 14 and 73% of papers that are internationally co-authored. Size here, so that's one of my, so the first three is my dependent variables, and all these others are my independent variables. Size here is measured by the total number of papers they produce. Okay? So that ranges from 718 to almost 30,000 in one particular year. And age is, you know, the number of years ago it was founded. Yeah? And that took us quite a while to find out, because these data are not in the Leiden database, so we had to collect for all the university the founding date. That there are issues about with mergers. People may even argue about the exact founding date. So we tried our best there. And then we also collected data on the population of the city in which the university is located, because I was interested in the question whether universities in larger cities would perform differently than in smaller cities. And turns out there's a difference, we see later on. Then we made three categories. Classical universities, that's always our reference group, versus technical universities versus medical schools. Okay, so to decide what university is a technical or a medical university, we looked at two criteria. Either they were self-declared technical or medical school. So many universities have this in their name, for example. But we also looked at the share of papers a university has in engineering sciences and in medical sciences. And for engineering sciences, that had to be 75%, including physical sciences, to be accounted for as a technical university. And for a medical school, we used a criterion of 50%. So any university that has more than 50% of their papers in medical sciences, we call it a medical school. Yeah.
Given it's one of your three indicators, internationality, there's an immediate problem that strikes me with that, and that is that it will depend heavily on whether you are a university in a big country like the US or a small country like Iceland. If you're at the University of Iceland, you want to collaborate, the odds are you're going to collaborate with somebody not in Iceland, so that you could easily get 70% collaboration. If you're in a US university, you want to collaborate with other institutions, but odds are it's going to be in another American one. So that's going to be very country-specific. Size of country.
Yeah. Yeah, we could have added the size of a country, but and that's probably what I still do, but we do already account for all the largest countries by dummies. Yeah, and these are the countries that have more than 10 universities in the Leiden ranking. So Brazil and Sweden were just out because they have 10. And these have more than 10. And you will see indeed that there are important differences in the level of internationalization that can be accounted for by these country dummies. So smaller countries tend to be more internationalized than larger countries, but it's not as clear-cut as that. Yes?
Sorry, Koen, very quickly. Did you have anything about ownership?
Private universities versus public universities. We thought of that, but it's quite hard to establish from their home pages. You really and very often it's mixed, and you cannot really find out the shares. Okay, maybe for a specific country we could do it when there's established lists on ownership or other kinds of organizational characteristics. Yeah. So from the shares of countries in the ranking, you for example see that 25% of all universities are from the US. Right, and here you see the other percentages for the other countries. Now, let's look at the correlation between these variables. Yeah? That's already interesting information to see if there are clear patterns. Well, some patterns I expected, some I did not really expect. So for example, size indeed correlates very strong with citation impact. Yeah? So papers produced at larger universities on average get many more citations. Right? Whether these citations come from people from the same university or from other universities, we don't know. Yeah? Surprisingly, universities in larger cities have less citation impact. So it seems that if you bear with me and see this as a good indication of quality, it seems that on average the high quality universities are outside the large cities. Cambridge, Oxford, and my feel is that actually, that's also from another paper I presented last week, that there is increasing evidence that for a university being located in a very large city has more disadvantages than advantages. And probably the main disadvantage is that the cost of living for staff and students is simply very high, which makes it much more attractive for both staff and students to go to other places. And maybe we could even think there is a more peculiar geography, is that the best location of a university may be in a small city, but close to a very large city. And geographers call that borrowed size. So think of Cambridge and Oxford. They do profit from the proximity of London in various ways, but they don't bear the downsides of London. So there's something to do more research about as well. What is also interesting to note is that quality and the extent to which you collaborate with industry is positively correlated. Yeah? So there's not really a trade-off there. Maybe it's more that industry is looking for the best science. But if anything, there is a positive correlation. And the same holds for the correlation between internationalization and university-industry collaboration is also a positive sign. So that may indicate that those universities that engage a lot in business, they are not necessarily universities that have a very regional focus. Even though policymakers tend to think about university industry in terms of regional impact. But that also comes out of a lot of other research, that university industry collaborations are equally insensitive to distance as university-university collaborations, meaning there's no really a peculiar geography of university-industry collaborations compared to other kind of collaborations. So many collaborations are actually with other regions in the same country or with places outside your country. and this links as a side note, to the European Commission's effort now to create yet another ranking. I don't know the name, but it's supposed to come out this year. They want to make 3 rankings on the best, on 1,000 universities. One on research, one on teaching, and one on something like social impact or impact. And to my surprise, I was told by people from Leiden who are involved in this project that the Commission wants to define social impact by regional collaboration. So apparently you're only supposed to help your region and not the rest of the world. So I think we need to counter also with empirical evidence this notion that social impact would be regional. Okay, good. Okay, this is the first analysis, and here the dependent variable is this mean normalized citation score. And you see that when you include more and more variables, you can really see what kind of university characteristics impact citation score. So larger universities have more impact, but if they're located in larger cities, their impact decreases again. But then if you really look at the size of these effects, this is a strong effect and this is a small effect. Yeah? So size here is really what matters a lot. Then technical universities outperform classical universities. That was a bit surprising to me, because we tend to think of them as more applied. But then you have to remember this is normalized by discipline, and within their discipline, technical universities may perform very, very well. Medical schools seem to have higher impact as well, but then if you start to control for country differences, this fades away. And this is probably due to the fact that the most, let's say, performant medical schools in the world are in the US. And then when you include the country domains, the US picks up this effect.
What's the country reference in there? Is there country
All other countries. Yeah. So all countries with 10 or fewer universities. So that's a heterogeneous group. Yeah, I could also have presented it differently. Doesn't matter. And then country dummies, you see UK, US, Netherlands performing quite well. Okay, France, Germany also quite well compared to the rest of the world. But there are marked differences. But here I want to actually discuss the meaning of these country dummies.
Sorry, what is it? So negative really means negative?
Yeah.
With respect to all other countries that are not presented.
Is Italy negative?
Yeah, well.
Yeah, but so
Japan.
That's not significant.
It's not Italy, it's Japan. Okay, sorry that it's not really clear. But these country dummies should not be understood as indicating differences in performance. A lot of things, it's a kind of black box, a lot of effects are confounded here. For example, first of all, ISI has a certain bias, okay? But you could argue that those countries who publish a lot in non-ISI journals would send their best papers to ISI journals. Yeah, so I'm not sure if the fact that ISI is biased towards English language journals would be beneficial for UK and US, but we don't know the exact effect. What we do know is there is this strong citation bias. People tend to cite people from the same country, but that already explains why US has much more impact, because there are much more fellow Americans that can cite you. And lastly, there are funding differences in the university system. So for example, we only look at the 500 best universities. That means that there are another, say, 10,000 universities in the world, not included here. Many of them come from the US. Because US has the best performing university, but they also have a lot of not so good universities. Yeah? Because they allocate their money in a very unequal way. So all these factors, institutional, geographical, ISI bias, are part of these dummies. So I see this as just control variables, not to be interpreted too seriously. So this is the main story. Yeah? Now, if you then look at university industry collaborations as your dependent variable, you see that the explanatory power of the model is much lower. Yeah, so we can explain very well citation impact, but we cannot really explain very well the share of university-industry relations. Here I want to note, as expected, technical universities have 1% more university-industry relations on average than other universities. And I also think it's interesting to look now at these country differences, because here they can be interpreted much more straightforward. Yeah? And here you see, for example, as expected, Japan, South Korea having much more university-industry interaction, but also the Netherlands, interestingly. Yeah? I knew that, but not many people know that. Okay, then internationalization. Here we see, this I find very interesting, that younger universities are more internationalized. Yeah? So that may be a strategy for new universities to climb the rankings, to climb, to get a good research going, to start collaborating immediately internationally. And then we also see important differences. Here UK is the highest after France in university in international collaboration. But again, the explanatory power is not very high. So, summary. We can explain citation impact quite well, but the other two indicators rather poorly. Size is very important in determining citation. And also interestingly, no country excels well in all three indicators. So there may also be, to some extent, trade-offs. Yeah? I already talked a lot about the interpretation of the country dummies. We need to be very careful there, especially when dealing with citation impact. And size as well. What does size mean? There are so many reasons why larger universities can have more impact. For example, reputation is very often not only correlated with perceived quality, but also with just knowing about the university. And larger universities are much more known around the world. The people's work may then be read more often. But there may also be indeed scale economies in research. There may be economies in doing interdisciplinary research. So that's still completely unexplored topic. If and what are the sources of agglomeration of scale economies at the university level? Final slide. What are my conclusions? Well, another thing that I didn't show you, but what is nice of regression analysis is that you have coefficients. So for a single university, you can compute what would be the expected value of that university and what is its real value. And that could be one way of assessing performance of individual universities. Is the university doing better or worse compared to what can be expected from that university being located in a certain country, having a certain size? Yeah? And then it may turn out you get a completely different ranking. Yeah? So that could be a kind of interesting exercise to do. But if you are an individual university and you are looking for a relevant set of universities to do a benchmarking exercise, then I think, depending on the indicator you look at, these are the relevant dimensions to delineate your relevant peer group. If you look at citation impact, look at universities of similar size, of course doesn't need to be exactly similar, but in the same size class. Don't compare with technical university if you're not a technical university, and look in your own country. Yeah? Given all those differences already mentioned between countries, why compare with uncomparable entities in other countries? For university industry, these are the only two variables I think that are relevant, and they are also less relevant given that the significance levels are a bit lower. And for internationalization, the only thing that really matters is what you actually suggested. It just differs for countries. Yeah? And there are no other structural variables that can explain it. And in particular, we saw that Asian countries are much less internationalized than, for example, UK and France. So the levels of their international co-authorships should not be compared with European universities. So I'll leave it at this. I'm happy to hear questions and suggestions.